Now we can look at the middle section. We have the object merge already in place. First create the combined primitive again with the divide and the facet node. I'm creating these blocks so that I can later on create cavities. These cavities will have the exact size to hold one of the grates. But to create any sort of cavity, we need these planes to become boxes. So create a poly extrude and increase the distance until it's roughly at the same height as the surrounding platforms. But before we continue with those cavities, I want to create little ramps at both ends of these blocks. As basis for that, we need the smaller side of the poly extrude. And there's an easy way to do that. For this one, we don't need to output the front. The only thing we are interested in are the sides. Each corridor block consists of 4 primitives, 2 of which are a lot smaller than the other ones. So create a measure node and set that to area. This will create the primitive attribute area with the calculated value for that primitive. Since I know that all corridors are only 2 panels wide and with the values I used so far, I can say that the sides I'm looking for will never have a value higher than 0.3. If you did something different, this value also might change, but you can easily find the right value by checking the geometry spreadsheet. But now that we have the side, we can create the ramp. Create another poly extrude and create a small box here. Not too much, this will only be a very short ramp. When you're satisfied with the distance, now use the inset to bring the outer points as close as possible. They don't need to be on the exact same position, they only need to be very close. To get a rough estimate where those points are, go into the geometry spreadsheet, and in my case, these points are somewhere around 0.05. The highest points of the side are at 0.1. With those values in mind, let's create an attribute wrangle. We know that the original points of the side are 0 and 0.1. That means we can simply create a condition. If the point position in Y is somewhere in between those values, it has to be a ramp point. And in that case, lower those points to 0. With the ramp points on the floor, we got ourselves a ramp. So let's head back to the idea of creating cavities. We already have a block as basis, and now we need a stencil to cut into the block. As a starting point for that, we use the divide node. Note that I don't use the facet node. In this case, I want individual points for each primitive. And you will see why. We do this once again with a for each loop, dealing with each corridor one at a time. First we create another divide node, and this time we use the breaker function 2x2. Deactivate the convex polygon, and now we already have shapes that are roughly the size of our grates. Then we can bring in the facet node and remove the inline points. When we use these shapes to cut into the block, we want to keep something from that block. So create a poly expand and here deselect output outside, the same way we did it last time. We need a bit more than a plane to cut into the block. So create another poly extrude and convert these to boxes. To create the cavities, we'll use a boolean node, so make sure you also output the back. In addition to that, we will most probably need a transform node to adjust the height of the stencil in relation to the block. So place the node and let's start by bringing it to its original position. Then grab the block and create the boolean node I was talking about. Then connect the prepared shapes into the second input and set the operation to union. I eyeballed the position of the shapes, so you might need to return to the transform node and adjust the position. And with that, the block is prepared, we have the cavities to hold the grates. That means in the next step we can bring those in. Start with a transform node and lift the plates just a bit before opening another for each loop. We used this approach a couple of times now. We take the original primitive and get its center point. Just make sure that the pivot is set up and scale it down to 0. After reducing the scale, we use the fuse node to get rid of the duplicated points. The remaining point will be the pivot point for the grate. So create a copy to point swap, connect the pivot point to the second input and bring in the grate with an object merge. This time we use grate number 2. The connecting pieces of grate number 2 have a clear direction which makes them perfect for the corridors. Let's connect the copy to points into the end of the for each and take a look at what we get. This looks not bad, but there's a problem. At the moment, all of the grades are facing in the same direction in the world space. They are supposed to go in the direction of the corridor. A way to solve that would be to use the method we used already in the window design. We only need to find the direction from one point of a corridor to another. To do that in this for each loop, we need the meta node. The tricky part in this situation is that the for each only uses one grade point at a time. But it's not only one corridor coming into the loop, but all of them. So how can we make sure that the point for the direction is actually part of the same corridor? I connected all of the incoming panels into a wangle, while the meta node is connected to the second input. Now the for each itself will take one of these panels. When I would just use all of the panels, the panel I would find would be the same panel as the one currently running through the loop. And that's why we set this wangle to primitive, get the detail attribute iteration from the meta node, and if that equals the primitive number, we're going to remove that primitive. Now the closest panel would be just another one of the same corridor. But again we need the center points of these panels so that the resulting direction is perfectly straight. So with the primitive node we reduce the scale down to 0 and use a fuse node to get rid of duplicate points. Now we have a current pivot point where we want to place the grade, and we got ourselves target points to find the right direction. Now to get that direction we need another attribute wangle. Here we will make that operation. We're going to place the wangle right after the fuse node and before the copy to point. Then connect the target points into the second input. We want to create a normal for this point so that the grade can orient itself alongside that normal. And the way we do that is fairly simple. First we get the closest point coming in through the second input with the function nearPoint, and then grab the position of that point, and the normal vector we seek is the normalized result of that position minus the position of the current point. Now it seems we created this grade on the wrong axis, at least if we want the wider elements to point in the direction of the corridor. Now to solve that, we could either create a transform node right after the object merge or in the grade geonode itself, or the way I'm going to do it by just creating a cross product from the current normal and the y-axis. This will also rotate the grade by 90 degrees. When we now zoom out of the scene, we should see that all corridor grades are pointing alongside their corridor. Now in addition to the grade itself, I want to add lights in the same way I already did with the floors and the gateways. To do that, just copy the transform that already has the pivot point around the center and bring that scale value back up to about 0.4. Create another copy to point swap, connect the small panel to the second input, and with the file node, we want to load the light asset. So create the file swap and under geometry file, select the light BGeo file. Again, for this model we don't want the point orientation, so deselect that option in the copy to point swap. Now let's combine the lights with the grades. Create the merge node and connect both copy to point swap to it. The result goes into the for each end node. Since we placed the lights directly onto the panel, we need to adjust the position in Y for the lights. So go to this transform node and bring the points slightly down. 0.1 should be enough. Now let's see if everything fits together. Here we have the main block, and when we template the grades, it should fall right into place. So let's create a merge node and connect these two elements. And I think that worked fairly well. Now in this network we now have quite a number of different elements. We have the grades and we also have the complete floor with the elevated platform. So let's also connect them into one merge. And we also have the created ramps. So let's not forget about them and throw them into the mix as well. And that is our floor network.